right, thank you, everybody. I am here to talk about Meshtastic, which looks like this, a Meshtastic node, or like this, a Meshtastic node, or even like this, a sort of BlackBerry-esque Meshtastic node, which is a lot of fun. Before we talk about that, a little bit about me, some fun facts. For me, 2005 was the year of the Linux desktop. I know a lot of us share in this. We've been doing this for a long time. I have baked a printer. I did IT work for a long time, and there was a time period there where lead-free solder was a thing, and there were a lot of printers dying, and turns out you can take the motherboard out of a printer and put it in your oven for 350 degrees in 15 minutes. Brings it back to life. I have virtualized SCO. That was a fun adventure. And more than once, and in fact 3 times, businesses have come to me with, we've got Windows 3.1 or Windows 95 applications that are super important for a business. Help, please. I threw it in DOSBox for them. So that's business background. I've gotten to do some very cool things, one of which is FLOSS Weekly. So we've got David Tott, rest in peace. We all owe him for Wi-Fi and internet being fast. He is one of the buffer bloat guys. And then Doc Searles, and I got to hang out with those guys quite a bit doing FLOSS Weekly over the years. Send me an email at floss@hackaday.com. Let's get you on the show. I also do the Untitled Linux show over at Twit, and we've got the man Leo Laporte jumped into one of our shows. Have a lot of fun doing that stuff as well. There we go, full screen. But these days, my full-time job is I work with Meshtastic. And you might say, some of you know, some of you don't. You say, what in the world is that? Well, first off, it's an open source project. I'm in the right place. We do an encrypted LoRa mesh network. We'll dive into each one of those and what they mean. We do off-grid communications, and that is the beauty of these. Essentially, I'll just tell you the real short version. It lets you send text messages even when nothing else works. And more than that, and because we're at the Ubuntu Summit, of course, somehow we're going to talk about Linux. We are on GitHub. We have more stars than that. We have over 400 contributors. We've got about a dozen people that we've elevated to leads in the project. And we are GPL v3, free as in freedom. Not everybody loves that fact, but we stand by it. We have sort of seen, well, an interesting trajectory. We were started back in about 2020. Kevin Hester was the guy that originally started it. Immediate popularity, and then sort of a plateau, and then something happened around 2024 and just whoosh, and we've taken off since then. And it has been quite a wild ride. So what is LoRa? Well, it's basically this and that on an SDR. It's a way to take information and put it on radio waves, and it's made by a company called Semtech. One of the most popular chips is the Semtech XX1262. You may have heard of LoRaWAN. LoRa is like the actual physical layer. LoRaWAN is a layer on top of that. We said we don't want to use LoRaWAN, but LoRa itself is pretty cool. It runs over the ISM bands. That's industrial, scientific, and medical. In the United States, that's like 915 megahertz. Here in Europe, it's 868. It can also run on the 2.4 gigahertz. It also runs on amateur bands. So if you're a ham radio operator, you can use Meshtastic as well in the ways that hams like to play with things. Something to remember is that LoRa is low bit rate. We're talking like dial-up days bit rate. A lot of our technical decisions are informed by this. Can you send pictures over it? No. Is it a replacement for the internet? No. But it is long range. In fact, that's what LoRa stands for, LoRa long range. And it's low power, even on the radio side. Our typical, the 1262, runs at generally 160 milliwatts. You can run it without a ham license. You can run it all the way up to a watt. And that is plenty of power. Our just about longest length that we have ever recorded was 330 kilometers. And you can tell that is literally mountaintop to mountaintop, but that was Italy to Slovenia. So long range. And this one is no hops in between. That's just a direct link from radio to radio. All right, let's talk about the mesh part of this. So generally the way you use it, you've got your cell phone, or you've got a standalone device, again, BlackBerry keyboard. Your cell phone will Bluetooth to one of the Meshtastic devices, and then it sends out over LoRa. You send a text message, hey, I'm here, goes out over the LoRa radio. The next one hears it and then goes, hey, this guy said, hey, I'm here, rebroadcasts it. Another one hears it. It's a hop to hop. Finally, you get to your destination. You may immediately look at this and go, it's wireless, it's meshing. Surely you guys use Batman routing, right? The answer is yes, sort of. Most of the packets that get sent with Meshtastic are multicast, essentially. And so for those packets, we use a smart flood algorithm, which, by the way, that's what Batman does too, if you use it with multicast. Smart flood, so we try not to rebroadcast any more than we need to. You will hear some criticisms of Meshtastic. One of the criticisms you occasionally hear is, they use flood fill still, they don't use Batman. Well, we use the Batman style routing for direct messages. When it's unicast, we use flooding for multicast. If you hear someone say that, they don't actually know what they're talking about. So we do encrypted mesh. So individual channel messages, AES 256, plenty of security. The US government says so. Direct messages, we have an X25519, that's elliptic key cryptography. I publicize my public key. The other guy publicizes his public key. We do a Diffie-Hellman exchange. Then we have essentially a new security key that only the two of us know. We are introducing XEDDSA signing. That is something that Signal came up with to be able to use the X25519 keys to do actual signing instead of just encryption. This is experimental. It's going to come out in 2.8, which is coming soon. We are TOFU, trust on first use. And it comes with being a decentralized mesh network. There's not a whole lot that you can do other than TOFU, particularly when you have 22 kilohertz of bandwidth and you're running on embedded IoT devices. There are some things coming that we can do that's a little bit better than TOFU. One of these is a key verification scheme where I say, hey, I've got my device, you've got your device. I'm going to hit some buttons. It's going to show you a pin, I type the pin in. It's going to show me a pin, you type the pin in, and then we know we're actually talking to each other. It's kind of a pain, but it's there, it works. All right, it is an embedded firmware. So let's talk about what we mean by embedded. I know most of us are Linux devs, we're used to full-on x86-64, or on the sort of lightweight side, we're running on RISC-V devices. We're running here on Nordic MCUs, basically 1 meg of flash, 256 meg of RAM. And these are single core. We also support things like ESP32. Those are dual core, but still embedded, very, very lightweight devices. Now, if you're an embedded developer, these are huge, but if you're a Linux developer, this is tiny. Okay, so what do people actually do with Meshtastic? Well, you send text messages. That's sort of the basic starting point. You can send text messages to everybody that shares your key, which there's sort of a public channel idea there, or you can send direct messages to one person. And then the other thing that people do with it is they share locations. And so these two screenshots actually came from OpenSauce last year, I think. And this is where some of the people that were running the Meshtastic booth were literally coordinating with, hey, where are you at? Here's where I am. Look on the map. You know, we share locations. Beyond that, people use it for off-grid communications. And this is sort of the real interesting thing that got me interested in Meshtastic. Shortly after I was introduced to it, I found myself, after a bad storm, running a chainsaw in my town. I started thinking, if this storm had been a little bit worse, what would I do? How would I be safe out here? How would I have communications if, like, cell phone network's down and something happens while we're cutting a tree apart? So I started thinking about that, and lots of people are thinking about this. But you also use it just out camping. And Kevin Hester, the guy that originally started it, he was into paragliding. It's one of the things that he did with it. Hiking, canoeing, all kinds of stuff people use it for. And then this thing happens out in the US desert once a year. These crazy hippies, and they would not mind my saying that, they pretty much agreed to it, Burning Man. And Meshtastic is nuts at Burning Man, so much so that they have to coordinate it and split it off into different mesh networks just to try to get everybody online at the same time. So we use it for all of these things. And then one other thing, and this is kind of the ham radio operators, they've gotten into it, and they say, you know, it'd be really cool is if, like, all the people that lived in the same city could talk to each other. And one of the big places where this gets used is, it's called the Bay Mesh. It's out in San Francisco. There's like 1,000 devices all in the same city. And trying to manage the bandwidth of that many devices sharing the same 915 megahertz spectrum slice is challenging. This is about the hardest thing that we have to deal with. It's our test bed hell, I suppose you could say. Work a lot with these guys to try to make things work out there. What else do people do with it? Well, they play games. There's BBSs. People play games like, I think this is Battleship, essentially. All kinds of fun stuff. People do pet tracking. This is interesting. This is interesting. This is actually ATAC, the Android Tactical Awareness Kit. Someone is using ATAC and a Meshtastic node to track a pet. And of course, you sort of apply that idea, and there's a bunch of other places where that might be interesting. You know, vehicle tracking, but also search and rescue. We've got a company that's wanting to use Meshtastic for firefighting and actively developing things for that. Emergency response, all kinds of stuff. You get up high enough and you can talk to any Meshtastic node you have line of sight with. We also have standalone. That is essentially what this guy is. It runs something we call the Meshtastic UI, or MUI, and you can load maps up on it. You can send direct with the keyboard, and then this is the base UI, base UI and MUI. But again, some devices have the keyboard built into them, and so you can send messages without having to have your phone connected to it. Now, all of this is text messages and position, but there's something else that we can do with Meshtastic, and that is we can send telemetry. Basically, you can send anything that can be represented in a small data packet. And so people send temperature, humidity, air quality, like an AQI, and then anything else that fits in that little data packet. Anything that could be sent in a small packet, you can send it over Meshtastic. And as you look at this, you might think, well, this sort of lends itself to agriculture. Yes, people use it for agriculture. Caring for pets, caring for cattle, all of those sorts of things. Yeah, there are people interested in doing that with Meshtastic. All kinds of things, location tracking built into the same database part here, and just all kinds of interesting data that you can pull. And people are all the time adding more sensors, coming up with new things. So you can, temperature on machinery, you can measure water levels, you can put an IMU on it and measure G-forces. I don't have the watch. There's a smartwatch that somebody makes, LilyGo makes, and it's got an IMU in it. It has a step counter built into it. And so we have a pull request open to support that step counter. And so you can, if you really wanted to, you could say, oh, at the end of the day, hey, I stepped this many steps today. All right. That's Meshtastic. What about Linux? Because that's what we're all here about. So Meshtastic is built on the Arduino libraries, which, yes, is why I was asking the Arduino guys yesterday about that. And there is a layer called Portduino that was originally built to do mesh simulations. And it was literally just this little tiny layer, just enough to get the firmware to run as a Linux daemon so that we can run a bunch of them at the same time and simulate the network. And I found this, and about the same time, I discovered that these existed. This is a WaveShare board that has a Semtech SX1262 on it. And normally the way that you talk to a Semtech chip is a few GPIO pins and the SPI bus, the SPI bus. There's a thing called a Raspberry Pi that has GPIO pins and a SPI bus on it. I wonder if I could make this work. And I basically chewed through the wall and made it work. Now, this particular WaveShare board does not have a TCXO on it. That's temperature-controlled crystal oscillator. So you start sending a message and it gets hot and your crystal drifts and you lose the end of the message. But there are people do now make boards that have TCXOs on them and they work much better. So why would you want to do this? What can you do with it? Well, we've gone on to add our MUI and base UI, both of them, can now run as a Linux application, and you can get that interface, which is really pretty cool. Our community has started making custom boards, mainly for the Raspberry Pi. And then there's this thing. So it's kind of a shout out to the Pine guys. They were the first one to realize that you could do this years and years ago. There's a little chip called a CH341, lets you have USB on one side and SPI out the other. And if you see the laptops here, each of these, no spoilers, but each of these has one of these little USB dongles that have a CH341 and a SIMTech chip. Oh yes, OpenWRT 1, the router from the OpenWRT guys, has microbus on it, and Micro makes an SX1262 chip. You can put them in there, and we've got packages inside of OpenWRT. You can run Meshtastic in your router if you want to. And then we've got a huge community that's messing around with these. These are the femtofoxes. This is a Linux board that gets real close to our embedded footprints, and they are thinking about solar-powered Linux, which is really, really cool in and of itself. So why would you want to do this? What interesting things can we do? Well, first off, I added something called host metrics. We talked about being able to send temperature over the mesh, humidity over the mesh, any of these things that you might want that fits in a small packet. And I kind of have a background doing things with like Cacti to monitor remote Linux hosts. And I said, well, wait a second. I could probably send the CPU temperature and, I don't know, our 1 minute, 5 minute, and 10 minute loads and some other things across the mesh. So we added host metrics. We've also got store and forward++. That was sort of the realization that there's a bunch of flash space and RAM on most of these Linux machines. We could probably save messages there in a really intelligent way. I would like to think it's intelligent. We can put them in a Git tree and then send them on. You can do packet dumps. Throw everything to a disk, look at it later. And then this is something else I've been working on recently. We can do fake SSH over essentially the direct message protocol that we have built into it. And then I want to brag about this thing just for a moment. This is a prototype, sadly a not working prototype, but it's a prototype of essentially this guy, the Meshtastic SX1261 and CH341 in a framework module. And I was in Embedded World, and we had one of our community members there, and I was just sort of talking out loud and saying, man, one of these days I'd like to have a framework module. And Iris, the community member that was there, goes, I can design PCBs. So I sent Iris a little bit of money, and Iris sent off for these. And unfortunately, the USB footprint inside of whatever CAD program Iris was using did not work, did not fit right. And so if you look really closely, there's been some modifications made to try to make that work, and they're not working yet. We're still making progress on it. I was hoping I'd have about 10 of them that I could give out to people that had framework laptops, but it did not work out, sadly. Anyway, we're going to try to do a demo. We're going to pray to the demo gods and see if this works. So up first, thinking about this idea of grabbing information from a remote node, you see here I've got framework, load, disk-free, and memory-free. That's this laptop. But the top row here is Pi 5 load, disk-free, and memory-free, and that is this laptop. We're pulling live data across the Meshtastic link and throwing it in just a very, very simple dashboard here through Grafana, but still shows that it's possible. But then that's really not enough. That's not interesting enough, I don't think. So we are going to cross our fingers and hope that this works. Hopefully we don't get a copyright strike. There we go, for the jumpy music. Okay, so I am essentially SSH'd. It's not real SSH. It is, but it is capturing ANSI commands and sending them across to the remote, and then capturing all the ANSI stuff and sending it back. So there's a few interesting things that work, like you can play NetHack. It's not a great experience, but it does actually work. Just to prove to you that this is actually doing what I say it's doing, we can run GLX gears. Oh, wait. Let's do it full screen. Give that a second, it'll catch up. When I worked on this last night, I tried that, and I went, wait a second, that's running Wayland. This is an SSH SSH session. How did that work? That's not supposed to work. I expected that to be really hard. Well, the reason is that the Meshtastic daemon is running as the user that's logged into Wayland. And we grab a new TTY under that same user so it can get to Wayland. I took a few minutes last night. Finally figured it out. We can do one other interesting thing here. I've got the firmware for Meshtastic loaded, and let's see here. Let's say that there was a bug, and it was super important that we fixed this bug, a security problem, we'll say. Which one of these do I want to look at? We'll look at flooding router, sure. So NetHack works. Nano, the best text editor, also works. And so if I wanted to, I don't know, let's go down here and say, was upgraded is default false. Let's say that we found a security vulnerability, and suddenly we say, it's super important that that is true. Did I mention this runs at like 22 kilohertz? It's not very fast, but you can do it. Yep, there we go. Write it out, exit, exit. Yeah, there it's catching up. Okay. Now, this was super important because it's a security vulnerability. Yeah, I got to type it right. That's fine, we'll get there. Bear with me. We're going to recompile the Meshtastic debinary because we can. One of the things that people always ask us about with Meshtastic, and of course, it's not connected to the internet. If there's any doubt whether I was faking it, it's not connected to the internet. See, it says so. One of the things people ask us about, though, is like, can we do over-the-air updates with Meshtastic? No. 22 kilohertz bandwidth, it's not enough. It's like trying to download something over dial-up, and we all remember how terrible that was. But this is really interesting because assuming that you run it online the first time so that it downloads all those packages, you could actually go in and fix something, do a hot patch, and instead of having to push the entire firmware over, you can just push a diff and then compile it and get it going again. So this is all super cool. This is the Linux stuff that I've been doing. I have a few minutes left, which is good because I have more slides. I'm going to talk for just a minute about open source in practice. Meshtastic shows up in odd places. For example, we talked about ATAK, the Android Tactical Awareness Kit. That gets used by US law enforcement. Meshtastic, because of the nature of it, gets used by US protesters. Sometimes at the same protest. And it's kind of, you have to stop and think about it. Like, what do you do about that? When you have in your Discord potentially law enforcement guys that want to use it for ATAK and protesters that are out there to protest the law enforcement guys. We have a very ideologically diverse community. We have gun nuts, we have cryptography nuts, we have people that want to send Bitcoin over Meshtastic. I don't have a whole lot of love for that group, but we let them hang out. All kinds of stuff. And we have come up with a solution. Sir, this is a Wendy's. Which essentially means that if somebody comes into our Discord or our comments or one of these places and starts trying to fight over this stuff, we tell them to knock it off and go fight somewhere else. And the reason that we do that, and I think this really is part of what it means to be open source, and the Free Software Foundation, I think, agrees with this, or at least they did when they wrote their Zeroth Freedom. Free Software Foundation, Zeroth Freedom, the freedom to run the program as you wish for any purpose. And then if you look at OSI, they have the number 5 and 6 in their guidelines for what it means for something to be open source. Number 5 is no discrimination against persons or groups. The license must not discriminate against any persons or group of persons. Number 6, no discrimination against fields of endeavor. Must not restrict anyone from making use of the program in a specific field of endeavor. For example, it may not restrict the program from being used in a business, for being used in genetic research, and in our case, in our example, we would extend that forward and say, may not restrict the program from being used in law enforcement or for protests. There are even more extreme places that Meshtastic gets used. I will just say that we have Ukrainian users and we have Russian users. And we have had a conversation with someone in the US government that suggested a course of action that we should take very similar to what happened in the Linux kernel. But beyond that, what we're required to do by law, we basically just, we stick with this. We put the software out, we care about software. We are not interested as a project in getting involved with either the political or the culture war things. And I think that's part of what it means to be open source. That's my opinion. Now, I get that it would be sort of hypocritical for me to tell you not to tell people what to do. There's a little wrinkle in there, but anyway. And then, if that wasn't controversial enough, we decided to make a business. Because we have the open source problem, which essentially boils down to, we also have to eat and pay rent. And AI, for all of the great things it has done for us, is also exhausting. Because you'll have, one overly eager individual open 10 pull requests, and then when you ask them about it, they say, oh, I'm so sorry, I didn't realize Claude was opening pull requests. I was just playing around in the code base. Thank you for that. And also, this community doesn't manage itself. There is occasionally the need to, at the very least, kick out the crypto scams out of the Discord channel. And someone has to deal with that. So what we've done is we've gone to the hardware vendors, basically the guys that make these, and we say, hey, open source, you're absolutely free to do whatever you want to, but if you are going to be officially supported, you get to help support the project. And then we're having conversations with people that want to do commercial use, like put Meshtastic nodes on cows, or, let me think about some of the different things. We've talked with some cities that have no communication. We talked with one group that, it was up in Canada, and they literally told us that half of the time the way people call 911 is by sending Facebook messages, because that was the only thing that would work. It's like, we can probably help with that. And then, of course, we also will do sponsored development. If someone says, I really need this particular feature, okay, fine, we'll price it out for you and we'll give it to you. And for now, at least, we are making this work. And it's been a lot of fun. It's been a wild ride, but a lot of fun.